When they mix water and syrup to make soda, they need to carbonate it. They do this by moving the soda into a tank, which is very cold, and then they add the CO2. They do this so more of the carbonation stays in the soda instead of escaping to the air. This is the reason why hot sodas go flat and why containers of soda can explode. Though CO2 doesn't have that much of a taste at all, and what you can taste is the result of the reaction between CO2 and water, and it's called carbonic acid. When the soda container is closed, carbonic acid can still break down into CO2 and water, but it will just go back to carbonic acid since the pressure in the container makes it go back into the water and react. When the container is open, the carbonic acid will still break down, but this time the CO2 will escape the bottle and the carbonation will have left the system. Okay, spicy foods taste spicy because of a toxin called capsaicin. When capsaicin comes into contact with your cells, it absorbs into your nervous system and binds to and activates your pain receptors, making a burning feeling. It's actually considered a neurotoxin. So why would we like to eat it? Well, the reason we like to eat it because it also releases endorphins. There's capsaicin right there. It's C18H27NO3. A pressure cooker worked by having a liquid inside of the cooker be heated to its boiling point, releasing steam and pressurizing the air inside the cooker, which raises the boiling point of the liquid to above its normal boiling point. This allows the food to be cooked faster without burning the outside of the food. Aside from less time spent, the reason you would want to do this is because as food cooks for longer, it loses nutrients and flavor. You know this is true if you ever had a well-done steak. It's true that a higher temperature destroys nutrients, but this isn't so much the case inside a pressure cooker because it's pressurized with steam. So by cooking with a pressure cooker, you can cook food faster and still have it be more flavorful. The purpose of slow-cooked meat is to retain the flavors of the meat without burning them off. It's simple. When you cook the meat at this temperature, it's not hot enough to destroy the nutrients while it still cooks the meat. This will give a more flavorful and juicy piece of meat, though because you cook it at a lower temperature, it takes longer for the heat to reach and cook the inside of the meat. Fruit ripens because of a chemical gas called ethylene. Ethylene reacts with oxygen gas in the air to form carbon dioxide and water. These products help speed up ripening. What actually happens during ripening is the starch in the fruit breaks down into simple sugars, which you taste as sweet. That's the goal of ripening, to make this fruit taste better so an animal wants to eat it. CO2 and water make that reaction possible. You can actually put a fruit in a bag or container to trap the ethylene gas inside, making it ripen faster. Browning happens when the inside of the part of the fruit that's now exposed to air turns brown. The oxygen and the enzymes work together to brown the fruit in a process called enzymatic browning. This turns some parts of the cell into melanin, which is brown. Ice cream is a combination of milk, cream, sugar, and air. It's called an emulsion because it's a combination of two liquids that don't normally mix together, fat and water. An emulsifier is a chemical that lets these two things mix together. In this case, it's lecithin, which attracts both fat and water. To make ice cream at home, you need to freeze the ingredients of the ice cream using ice covered in salt. The salt's very important, it makes the ice colder. The way it does this is by lowering the freezing point of the ice, making the ice melt. Melting is endothermic, so it takes energy and heat away from its surroundings to do that. If you try to make ice cream yourself with no ice and salt, or just with ice and no salt, ice cream will stay as a liquid because the ice will not absorb enough heat for its surroundings to freeze the water, fat, and sugar. Most pots and pans are made of stainless steel or cast iron, which have a specific heat capacity of 0.5 joules per gram and 0.451 joules per gram. Because of this, the stainless steel pan will heat up faster and lose its heat faster, and the cast iron pan will take longer to heat up. And take longer to heat up and will stay hot for longer. This is the reason why a cast iron pan should be heated and cooled slowly, because it can warp with temperature fluctuations if you heat it up on max heat or cool it down with water. The reason for that is because it likes to release its heat slowly, so if you force it to do it faster, it could warp. When you make wine, you crush grapes into juice and add yeast. Yeast turns the natural sugars from the juice into ethanol and CO2. The way this works is that as the yeast multiplies, it quickly uses all the oxygen in the juice. So the yeast switches to anaerobic respiration, which is called fermentation. In this process, the yeast breaks down sugars to create energy. The byproducts of this reaction are ethanol, which is alcohol, and CO2. The CO2 byproduct from winemaking is not needed for anything, and it just gets released into the air. A nonstick pan is coated with PTFE or Teflon. PTFE is resistant to high heat and has very low friction. It is the third lowest friction coefficient of any material, which is 0.05 to 0.1, and that's why your food doesn't stick. PTFE is also inert, meaning it doesn't react with other chemicals, which is why it's safe to eat. It will just pass through without causing you any harm. There's a misconception that nonstick is harmful to you. Some people think this because there's a chemical PFOA that was used in nonstick coating until 2013. PFOA is slightly harmful and linked to cancer, but once again, they don't use it anymore. There's a PTFE molecule right there, and it has low friction because it's so close together like a chain, so things just slide over it. Caramelization of sugar starts at 320 degrees. That temperature breaks sucrose molecules into fructose and glucose. These two molecules get oxidized with a high heat and then turn into maltol, which tastes like caramel, acetic acid, which is sour, and furan, which tastes like nuts, like a nutty taste. Okay, conventional ovens use radiant heat from gas or electric heating elements inside the oven to cook food and do not have a fan to circulate the hot air. Because conventional ovens are so large inside, it takes a ton of energy to heat the inside of them, so they aren't efficient for heating a small portion, or compared to microwaves. Microwaves use electromagnetic waves to heat food. The microwaves make the water molecule in the food vibrate and move, and the heat made from the friction of that is what cooks the food. A microwave is the most energy efficient way of the three to heat food because the energy is absorbed by the food and not the air around it. An air fryer works like a small oven with a fan to circulate air. They are more efficient than a conventional oven only because the volume they need to heat is smaller, and they're good at making crispy food. The independent variable is the lemon juice. The dependent variable is the amount of browning, and the control is the half of the apple that doesn't have any lemon juice on it. So I'm going to cut the apple in half, put lemon juice on half, and see which one browns more. So with this apple cut in half, I'm going to put one side in the lemon juice, and the other side will have no lemon juice, and we'll see which one turns brown after an hour. And you can see the one with the lemon juice didn't turn brown, but the one without it did. And the reason that the half with the lemon juice didn't brown is because browning is an oxidation reaction, and lemon juice is an antioxidant, so the reaction can't happen.